Alrighty, hello everybody. Here is your key for your PB.7 to PB.15 review sheets. These first four problems we've got to solve by factoring. When your leading coefficient is 1, so the number right there, you're just looking for two numbers that multiply to get 6 and add to get -5. And so we can double bubble that into x minus 3 times x minus 2 equals 0. Because -3 times -2 is 6, and -3 plus -2 is -5. And then you set each bubble equal to 0 separately and solve. So I'll show this step here. I probably won't show it on future problems, but we're setting up these two different equations and solving for x in each of them. So from this one we get x equals 3, and this one we get x equals 2. So those are our two solutions to the first problem. Number 2 is like number 1, except it's not equal to 0 yet. So first we need to subtract 18x, or sorry, just 18 from both sides to get that. And then you can double bubble from here. So we need two numbers that multiply to get -18, but add to get 7. So that's going to be +9 and -2. And then again, you set each of these equal to 0 separately, which I'm not going to show that step. So you get x equals -9 and x equals 2. Which you can just write your answers like this. Don't put them in parentheses though, because then that looks like an ordered pair, which it's not supposed to be. Okay, coming up to number 3. Now this one's going to be more difficult because our leading coefficient is not 1. We still got to set it equal to 0 first, so we got to take care of that 11x. So first subtract 11x from both sides, and I'm going to write it in standard form. So it goes x squared, then x, then the term that doesn't have x in it. And we are going to double bubble. But this time when we double bubble, we have to multiply to get this. So our only option is 3x and x. And then the two numbers we put here and here do have to multiply to get 10, but they no longer are going to simply add to get -11, because whichever number we put here gets multiplied by 3 first, then added to whatever we put here times, in this case, 1. So we do have to multiply to get 10, though, with these two numbers. So it looks like it's going to be, if I put a -2 here, and I'm just guessing and checking in my head real quick, actually. So if I put a -2 there and a -5 there, what that will do is I get -5 times -2 is +10, but now I do 3 times this to get -6x, and -5 times x to get -5x, and then combine those to get -11. And so that's how you know that this is right. Then you set each bubble equal to 0. I'll show it again on this one. Because then the first one, you have to add 5, and then divide by 3 to get x equals 5/3. And on this one, you just add 2 to both sides to get x equals 2. And so those are your two solutions there. All right, on number 4, same thing. Our leading coefficient is not 1, so it's a little trickier. And it's not equal to 0 yet, so you have to get this set equal to 0. So subtract 24, so it's equal to 0. Now in this one, the easiest way to do it is we actually have a greatest common factor here. These are all divisible by 2. I don't think we did a lot of problems like this in class, or if it came up, we didn't necessarily talk about it. But you can divide them all by 2, or so in other words, you can take out a 2. You can also divide both sides of your equation by 2 if you want to. But if you take out a 2, then you get x squared plus 4x minus 12 equals 0. And now you can kind of ignore the 2, because no matter what we get in here, if this ends up being 0 and then you multiply by 2, you're still going to get 0. So we can just double bubble this like normal, because now our leading coefficient is 1. So you need two numbers that multiply to get -12, but add to get 4. This 2 is still here, but it's unnecessary. It's not needed for the rest of the problem. So 6 times -2 is -12. 6 plus -2 is 4. And now you can set each bubble equal to 0 separately to get x equals -6 and x equals 2. So that doesn't always happen, but when you have a number that they can all be divided by, you can go ahead and divide it and make the numbers smaller, like we did here. All right, now we're going to solve by square rooting both sides. So this is where you get the thing being squared by itself, and then you square root both sides. So the first step on this one is divide both sides by 25. And now I can square root both sides. So I'll show that here. But remember, whenever you square root both sides, you got to put that plus or minus. So you get x equals plus or minus the square root of 16 over 25. But you can square root both of those numbers, so it's just plus or minus 4 over 5. For square roots of division or multiplication, you can just square root each number individually, and that works. Not for addition or subtraction, though. All right, on this problem, we don't have the square term by itself. We need this all on its own, so get rid of the 6 first, and you get x plus 4 squared equals 36 when you subtract 6 from both sides. Now we're ready to square root. So we can square root here, square root there, put a plus or minus on this side, and you get x plus 4 equals plus or minus 6. Subtract 4, and you get x equals negative 4 plus or minus 6. And so that means we're going to do x equals negative 4 plus 6, and we're going to do x equals negative 4 minus 6. This gives us negative 10, and this one gives us positive 2. So those are our two solutions, x equals 2 and negative 10. I'll put equals x here. All right. So 7 is going to be a slightly more complex version of 6 because we have another number out here. So first I would add 5, turning this into 2 times x minus 3 squared equals 50. Then divide both sides by 2. Giving us x minus 3 squared equals 25. Now we can square root both sides. Put a plus or minus because we square root of both sides, and you get x minus 3 equals plus or minus 5. And now you can add 3 to both sides, so x equals 3 plus or minus 5, which means we get 8 and negative 2. So those come from doing 3 plus 5 to get 8, and then you do 3 minus 5 to get negative 2. All right, now we're going to solve by completing the square. And completing the square is going to turn into a problem like, once you get to this step on each of these problems, is what we're turning these problems into. So when you complete the square, we ignore this number, or you can add it to the other side, or the number we're looking for is this number divided by 2 squared. So we want this number to be 9. So you can figure out what to add to this number to make it 9, or move it to the other side. So x squared minus 6x equals 14. Divide this number by 2 and square it. So that's plus 9. So you add 9 to both sides, add 9 over here. And now that makes this side double bubbleable, which is the whole point. It's now x minus 3 squared equals 23. And now we can solve by square rooting, which was the whole purpose. So now it's just like the problems from before. Numbers, what was it, 5 through 7? Yep. And put a plus or minus here. And so you get x minus 3 equals plus or minus the square root of 23. See if you can simplify this, but we can't. And now you can just add 3 to both sides. So you get x equals 3 plus or minus the square root of 23. And there's nothing else you can do there. So that works out nicely for us. On number 9, we don't need to set it equal to 0 when we're solving by completing the square. We actually want just these two on one side. So now we can complete the square. X squared minus 2x. We're going to throw another number into the mix. Divide this by 2 and square it, so it's 1. So we're going to add 1 here and add 1 here. That makes us double bubbleable into x minus 1 squared equals 4. And then that allows us to square root both sides. Square roots plus or minus. And so you get x minus 1 equals plus or minus 2. And then add 1. And then once again, we're going to do 1 plus 2 and 1 minus 2. So 1 plus 2 is 3, and 1 minus 2 is negative 1 to get our solutions for x there. Okay, this one is kind of the same as the other ones, except I put the 6x over here, so just move that over there first. So it's x squared minus 6x equals 3. I'm leaving a blank space for our missing number, which is this divided by 2 squared. So add 9 to the other side, and you get x squared minus, x minus 3 squared equals 12. And now we can square root both sides, because we have a thing being squared by itself, and you get plus or minus. So we have x minus 3 equals plus or minus the square root of 12. Try to simplify the square root of 12, which is 4 times 3. So we can turn this into x equals 3 plus or minus 2 square root of 3. And nothing more you can do there. Okay, and then finally we have quadratic formula, which is written right here for you. Just make sure everything's set equal to 0 before you use quadratic formula, so we'll manipulate those two. But this one's ready to rock. A is this number, -2, B is -7, and C is 2. So it's x equals the opposite of B, so 7, plus or minus the square root of B squared. Remember, this number will always be positive because you're squaring it. Minus 4 times A times C all over 2 times A, so 2 times -2. And now, again, I think the easiest way is to get this number first and then do 49 plus or minus whatever you get here. This is going to end up being a plus number because of a negative times a negative. So we have 7 plus or minus the square root of 49 minus, that looks like it's going to be 16 over -4. And that just gets us 7 plus or minus the square root of 33 over 4, which there's nothing to be done there. You check 33 for a perfect square factor, and then remember if the number here and then a number here, if there was one other than 1, and this number, if they're all divisible by the same thing, then you divide them all by that same thing to reduce the fraction at the end. Okay, so that's that one. 12, we got to set this one equal to 0 first. So it's 4x squared minus 4x plus 1 equals 0. If you wanted to, you could take this to the other side. Your answer will look slightly different, but they actually would be the same. I like to keep my leading coefficient positive, so I keep it there. So we have x equals the opposite of b, which is 4 from this number, plus or minus the square root of b squared, minus 4 times a, which is 4, times c, which is 1, all over 2 times a, which is 4. Okay, so again, simplify this first and then square that and subtract. And this time we get 0 underneath the square root. So now we have x equals 4 plus or minus 0, because the square root of 0 is 0, over 8. And so when you do 4 plus 0 and 4 minus 0, you get the same answer. So this one just ends up being 4 over 8, which is 1/2. So you only get one solution. Technically, you get the same solution twice. Well, that's really just one solution. Okay, and then finally, we have another quadratic formula problem right here. Add this over to here to make it positive and to set it equal to 0. Again, you don't have to make it positive. You could take these two terms to that side if you want. But it's 2x squared minus 7x plus 7 equals 0. And once again, we're going to do x equals the opposite of b, which is 7, plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which gives us that. And then we simplify underneath, so you get x equals 7 plus or minus the square root of 49 minus 56 over 4. And that equals 7 plus or minus the square root of -7 over 4, which means now we get two imaginary solutions, which we haven't learned how to do that. So we're just stopping here and saying 2 imaginary solutions. And you can stop. And that's it. Thanks for watching.